Hi everybody, today we're going to take a look at modeling temperatures with trig functions in Desmos. Trigonometry models are useful for cyclical phenomenon, things like weather, tides, and sound. Sine and cosine functions can help us capture repeating patterns for describing the periodic behavior. We're going to use a synthetic dataset of daily temperatures, both the minimum and the maximum, and model those temperatures in Desmos. Let's start by taking a quick look at our data. I have a column for the day of the year, and it goes from 1 all the way down to 365. The next column gives the minimum temperature on that day. Then our third column gives the maximum temperature on that day. All of the temperatures are given in degrees Fahrenheit. I want to copy this data over into Desmos. To do that, I'm going to hit Control A, then Control C. Control A was select all, Control C is copy. Then in Desmos, I'll go on my top line and I'll hit Control V for paste. Here I can see all of my data. We can look at them one at a time by clicking on and off the different columns. Let's start by looking at the minimum temperature. Before Desmos makes our mathematical model, let's take a minute to talk about what that is. A model is just a mathematical way of describing reality. Instead of listing every temperature for every day, we can use a trig function to capture the overall pattern. It won't be perfect, but it gives us a powerful tool to understand and even predict what's happening. In any function, you have an independent and a dependent variable. In our case, the day will be the independent variable. The dependent variable, which will be the y, or the z because we have two columns, will be the temperature. When looking at our trig model, we're going to use one of the two functions, f of x equals a sine bx minus c plus d, or f of x is a cosine bx minus c plus d. Instead of writing f of x, we're going to type in y1. This tells Desmos to look at the table that we originally put in. Then we use tilde to tell it to approximate the function. You can find that on your keyboard, or you can open the keypad, go to the letters, look on the bottom, and you'll find the tilde on the bottom row. Then we'll type a times sine, put a parenthesis, bx1. This tells Desmos to look at our original table. Remember, we're putting minus c and then plus d. Now we have a nice curve that closely matches our original data points. When you scroll down, you can see that Desmos gave you values for a, b, c, and d. Let's do the same thing with the maximum values. I'm going to turn z on, and let's get rid of y and the model we just found. This time our dependent variable is z1. Again, we say is approximately. Don't use a, b, c, and d again when you do the second model. That can be confusing to Desmos because it already has values for a, b, c, and d. I'm going to again use sine. I'll do v x1 minus w plus t. I just want to make sure I use different letters for my second function than I did for my first one. Again, I can see the values for all the variables. Let's click the other values back on so you can see what happened. The values for d and t really show us how the temperature changed from the minimum values to the later higher values in the day. Now that you have all the values for your variables, you could easily identify the amplitude, phase shift, period, and vertical shift for both the minimum and the maximum temperature.